Parallelization. Parallelization is the type of computation in which many calculations or the execution of a process are carried out simultaneously. In many areas of scientific, mathematical, and artificial intelligence programming, the solutions to problems are represented more naturally as a collection of simultaneously executing tasks. This makes parallelization very valuable. Major advancements in environmental modeling, space exploration, and several areas in biological research, such as the Human Genome Project, have come directly as a result of parallel computing. The two main types of parallel computing that we will discuss are data parallelization and task parallelization. The key differences between the two are what gets distributed in parallel.
Task parallelism is the simultaneous executions on multiple cores of many different functions across the same or different datasets. As a simple example, if a system is running code on a two-processor system, CPU A and CPU B, in a parallel environment, we wish to do task A and B, it is possible to tell CPU A to do task A and CPU B to do task B simultaneously, thereby reducing the runtime of execution. A drawback of task parallelism is that it is not scalable, which brings us to our second type, data parallelism.
Data parallelism is simultaneous execution on multiple cores of the same function across elements of a dataset. An example of this is if you want to sum all the elements of an array and the time for a single addition operation is TA time units. In this case, with sequential execution, the time will be n, which is the number of elements in the array, times TA, which is the time units, to sum up all the elements of an array. With data parallelization, if we execute a data parallel job, and let's say we use 4 processors, the time will reduce to n divided by 4 times TA plus the merging overhead time.
As mentioned before, a parallel computer can be characterized as a set of multiple processors and shared memory or memory modules communicating via an interconnection network. There are 2 structural classifications. A shared memory computer, or tightly coupled systems, is when multiprocessors communicate through the global shared memory modules.
Similarly, when every processor in a multiprocessor system has its own local memory, and the processors communicate in messages transmitted between their local memories, then this organization is called distributed memory computers, or loosely coupled systems.
In simple terms, parallel computing is the simultaneous use of multiple compute resources to solve a computational problem. Here we have a visual demonstration where multiple problems are being solved by multiple compute resources simultaneously.
Bye.
Bye.